Hello and welcome to Stats Session 3. So I am Dr. H, and with me today is Shadna, the moderator. So as you have questions, you can type them in the feed. Shadna will see them and will feed them to me. And the person handling all of this, without whom none of this would be possible, is of course Brian. So I know you've been here for twice before. This is our session for the for what I call the long question. So let's get started. So basically what I'll be talking about is the 2021 AP testing, preparing for the AP stats, and how we at Princeton Review can help you prep for your AP. Okay, so you have seen this slide before. The test dates are May 17th, where it is local in your school. It's a paper and pencil test. It'll start off at noon local time, and it's only offered in your school. May 25th is the second administration, which is again another paper test. And so it is 12 p.m. local, noon local, and it is in your school only. The digital version is offered on June 10th at 4 p.m. Eastern Daylight Time. So it's the same time for everybody. So that means some of you will be taking it earlier in the day. Some of you might be taking it later in the day. Depends on where you are. It is digital and based on the decision that your school makes. Either you have to take it in school where they will, you show up and it's got to be monitored in a computer lab, or you take it at home. So this time I did not put in what is on the test. We covered that extensively yesterday, so I'm not going to cover it today, but I think it is useful actually to put up what actually is covered on the test and what percent of each. Now, as you see, uh, the big hitters where the weights are collecting data, probability, random variable, and probability distributions, and then making inferences from those data. So that's what these questions primarily center on. And you can see that in the distribution of questions that come your way. So today we'll be looking at what they call the investigative task. I have some example questions here, and these are the super long questions. These are the ones where they ask you to spend 25 minutes on the question. So really what this question is testing or trying to get at is your ability to reason statistically, statistical reasoning. And if you are going to reason statistically, what they are asking you to do is also justify your answer. So the more you can explain, the more you can justify, the better your grade will be. So that's what they're looking for here. Of course, they have to give it to you within the context of a question. So that's what we are looking at here. But the justification will be there. Realize that what you see in your textbooks, the textbook examples are, the pure best case examples. These cases will not be as pure. There will be some gray area here. So, that is what they're trying to test. Can you navigate through the gray area? There are some things where you can take certain liberties and others where you can't. So what are some of those things? The obvious ones are, if you get a negative probability number, that's not going to fly. If you get a probability number of greater than 1, that's obviously wrong. I mean, the justification might be good. Maybe you made a calculation error. And if you get something like that, make a note saying, I don't think this answer is right. And this is why. You will at least get partial credit for that, at least noticing that. So if you notice those types of errors, especially in these long questions, write that down. Because that's really what they're going after here. Can you reason, and then do your answers look somewhat reasonable? So maybe one of the first things is that do not leave common sense at the door. Take common sense with you and use it. So let's take a look at this question. Uh, Tennis, anyone? So, sports analyst is specializing in tennis players and their relative success rates. So essentially, we are looking at, hey, the more a player has been playing, the more Grand Slams he would win. And the report is based on a study of a random sample of 24 males ranked in the top 24 last year. And this information was collected for each player. You know, how many Grand Slam titles he had won and number of years he had been playing. So, does the scatter plot support the analyst's statement? It seems to. I mean, there is a lot of scatter here, but it does seem to that it looks like, I can draw a line going this way here. So it seems like the number of years, the more number of years somebody has played, the more Grand Slams that person wins. So it seems like the scatter plot supports the analyst statements above. Okay, so notice that what I'm trying to do is use the words that the grader would be familiar with. These are statistical terms, positive association between the two variables. So now I can, that is a defined term. So I can use that and say, because there is a positive association, therefore it does seem to support the analyst's hypothesis. Okay, so typically with these parts, with these questions, they're like around 5 parts per question. The idea is you want to answer them in order because the first one is relatively straightforward, and then what they do is they will add a twist to the question, and then you have to work with the twist. So the first couple of questions, what they do is they try to get you familiar with the situation, and then they add the twist, and then they ask questions after that twist. So that's the way it is. So here is the next one. This is the same question as was on the previous slide, so I'm not going to read it again. Here, the table shows a computer output of linear regression analysis. Identify the slope of the least squares regression line and the intercept. Okay, so basically this is what you would have on a standard ANOVA table. So the slope is 1.89 because we have number of years played coefficient. So for each additional year a player plays tennis, his predicted number of Grand Slam wins increases by 1.89. Okay, so that's what this predictor is. Okay, so I told you they're going to throw in a stinger. Here's the stinger. So the stinger is a different analyst in the field came across the same data and decided to perform a new analysis, this time by separating the data by type on court played. The revised scatter plot identifies the courts the matches were played on, and that's what it's shown here. Based on the players in the sample, describe the association between the number of Grand Slams won and the number of years that these players played on grass courts. So notice the grass courts are here. And now it's the same data. If you take a look at this, it's the same data, except now you see that instead of the positive correlation that we were seeing, now we start seeing negative correlations. Okay, ouch. So they really actually pulled a surprise here. This is uh, like a surprise clue when someone says, "Here, let me look at this," and all of a sudden your hypothesis is turned upside down. This is essentially what's happening here. So for Grand Slams won on grass courts, there's a strong negative linear association between the number of years played and the number of Grand Slams won. So players that have been playing the longest, which is down here, have won fewer Grand Slams than those that have been playing more recently. And actually, the same trend is true for the other courts as well. Okay, so you surprised? You may or may not be surprised, but this is where I think if you watch mystery movies and things like this. So this is when the detective makes a revelation and you go, oh my goodness, I never even thought about that, although all the clues were right there. Okay, let's take a look at D. Based on the players in the sample, compare the median number of Grand Slams won on the 3 types of courts. So this one here is not too bad, right? I mean, here they are roughly arranged, so I can find the middle number and see how many years they were. And if you do that, basically what you have, Grand Slams played on the grass court have resulted in a median of 3.5 Grand Slam wins. Now, you say 3.5, why? Because we're at about here. Okay, notice that that's where we are. And, yes, you may debate whether it's really 3.5 or 3.2 or where you are. Notice that these are the lower 4, these are the upper 4. So it's in between these 2 points right here. It's in between, let's see if I can highlight those 2 points. Yeah, it's between these 2 points right there. Okay, now if you're close enough, the grader is not going to mark you off, and the grader will say, okay, fine, that's okay. Here we have the same thing. Remember that I want years played, right? So that's what we're looking at here. So the ones on clay courts have 6, which is here, okay, approximately. And those that have played on hard courts have resulted about 7.5. So here are the lowest 3. So it's really between, we'll say about these 2, where we are looking at the median. So this median is about here. Okay, remember the median is the middle number. So it is a middle number based on years played. So that's why I'm looking at it this way. Okay. Here it is between these 2. Okay, well, what's nice about that one is because it's a long line on years played, at least it's a flat line compared to a number of years. So that helps me out a little bit. Okay, and then it says, based on the analysis conducted by this new analyst, how could the original analyst statements be modified to better describe the relationship between the number of years a player has played tennis and the number of Grand Slams he wins for the players in the sample? Okay, well, the previous analyst, one of the things you want to do is instead of saying the previous analyst was wrong, remember we supported the previous analyst when the data were presented without this additional information. So what we can say is we can say the previous analyst should have considered the additional information because it really changed everything around. So the way you could say it is that the original analyst statements should have included the type of court played on. Overall, the hard courts yield the highest number of Grand Slam wins because they're up here, the highest number, followed by clay and grass courts respectively. But within a court type, players that have been playing longer tend to win fewer Grand Slams. So that's one way of interpreting the data here that we have. So you want to make statements that can be supported by the data given. Okay, so that's how they would test this one for sample 1, for sample question 1. Okay. Let's take a look at the next question that I have. I have a sample question 2. A clothing company sends out frequent emails to its customers. The emails include a link to a discount code. The company records how many customer clicks on the link, how many customers click on the link for each email. So here's some more information about the same thing. Historically, the average click rate, proportion of people who click on the link, over the past 2 years has been 0.155. Last month, people on the marketing team at the clothing company decide to explore changing the design of their emails, and they want to know whether the click rate of the new design is higher than the existing click rate. Of course, marketing, they want to do their job, they want you to buy more, and what's more exciting than buying more clothing, right? Uh, so of course, that's why this example came into being. The marketing people want to do an experiment to help decide uh, the design to use for their email. They design an experiment, and where they, we are being asked then to design an experiment where they could, which they could use to actually answer this question. So now we have two things. We have a rate that we know, and we want to know if the new design is actually will give us a higher click rate than the old design. So of course, what we want to do, we've learned from stats that we want a random sample. We don't want to fall into any of the biases, and that's the best way to pick one is a random sample, and see if the click rate is higher than 0.155 or lower than 0.155. Because while they may have done a good job, uh, the ad is so distracting that they don't even click the link. So the clothing company could randomly select, and I just picked this number, 1,000, a large enough sample, using a random number generator. So this way there is no bias. So this is basically to make sure that there's no bias, and send them an email with the new design. So historically, we know that the click rate has been this. Okay, the click rate for the new design can now be compared to the historical rate, and that way we can determine whether it is a better design or a worse design. Okay, so here they're asking, describe the statistical test that the marketers should use on the experimental data they collect. Include a statement about the null hypothesis, alpha level, and what the critical statistic should be. So these are the things we need to pay attention to in your response. So they're trying to, they're trying to help you with your statistical thinking by giving you things like this. So let's take a look. For this experiment, basically this is a one proportion z-test, because you really want to know, the click rate is being compared to 0.155. So you want to know whether it is greater than. So the hypothesis could be that the click rate for the new design is less than or equal to, since the question that specifies the marketers, the the question specifies that the marketers want to know if the new design has a higher click rate, right? So this is what we know. Does the new design have a higher click rate? Not a different click rate, but a higher click rate than the old design. So we have our new hypothesis that the click rate is less than or equal to. Alpha is 0.05. And really what I want to do is I want to reject this null hypothesis so that I can say, okay, I have rejected the null hypothesis, and therefore the click rate is indeed greater than 0.155. So the z-value at an alpha level of 0.05. Now, if you don't know any better, the standard alpha value to use is 5%, 5% confidence interval. So the critical z-value is 1.645. Now, if you've done enough statistical work, you probably have this number memorized in your head anyway. I do say remember to look up the critical value for this one-tailed test, but ideally by now, towards the end of the year, you would have this number analyzed, memorized anyway. So this is how you would actually perform. Notice that there are no data that we've been given. You have just set up the shell. So when the data do come in, you plug them in, you crunch the numbers, and then you say, okay, this is what I have found from setting up the numbers. What makes this question a little bit harder is typically you have the data ahead of time. And for some reason, for some some people might say odd reason, if you have actual numbers, thinking through the problem with the actual numbers makes it a little bit easier. Here we don't have the actual numbers. So this is where if you don't have the actual numbers and you find it easier to have the actual numbers, what you can do is you can say, okay, supposing I have these numbers, and craft your answer that way. And as you craft your answer that way, now as you are writing, remember to write a more generalized response because they didn't give you any data. It's just sometimes a lot easier to think of this in terms of the data, in terms of the tables that they may have given you. Okay. So here is where the twist comes in. The marketing manager now tells the team that switching to a new design will be very costly, so he wants to make sure that the switch is worth it. A very small increase in click rate is not worth their time. So they want to be careful about deciding. They only want to switch if the click rate for the new design will be at least 0.01 higher than the click rate of the old design. Okay. And then it says describe at least one way in which you could alter your experiment or the statistical test to address these new concerns. Now, initially, what were we doing? We were actually using 0.155. Now, with it has to be higher than uh, you know 0.165. What do? Well, I didn't do anything with a 0.155. I actually took it as this is my standard of comparison. Now I just have a different standard of comparison, a slightly higher standard of comparison. So what I'm going to do here in my response is put down, the marketing manager's statement suggests we're looking for evidence for a click rate that should be 0.165 or higher. So all we are doing is now we are changing our null hypothesis. Okay, so it does not have to be 0.155. We could change that number, but we didn't do anything with that number. But the data would then dictate whether it is indeed whether we can accept or reject the null hypothesis with the new number. So the rest of the analysis would pretty much be unchanged. I mean, okay, the z-values will change at the end and things like that, but really all we are doing in essence is changing the value in the null hypothesis, and that will drive the other values in our problem. Okay, so now this question is particularly fiendish because they throw in another set of considerations. Okay, so this is the same question that we had before. And now we have the company also collects a few pieces of demographic data about its customers. This includes a customer's self-identity preferred clothing category. The table below shows the frequency of each size category of a randomly selected email from 2 months ago. So these would be the sizes that they have: petite, typical, plus size, and maternity. And now whether it's a clicked or not clicked. From this email, what is the probability of clicking the link given for your self-identified category if your self-identified category is maternity? So I should change that. Okay. So here it is. To calculate the probability of clicking the maternity size, you only need to look at people here who self-selected this category. The total number of people in this category is basically the sum of clicked and did not click. Remember, it's a good idea to have totals on two-way tables. So sometimes you will see totals down here and totals here. You don't have to do that. It's only one question, so you don't have to do that here. You can certainly calculate the totals here. It's only one column you're looking at. And so the probability is 125, those who clicked, over the total number, which is the sum of these two, which gives me a 13%. So of those people who self-identified as maternity, 13% of them clicked. Okay, so now we have another curveball thrown at us. So the marketers are looking at the location of customers. Since the company operates only in the United Kingdom and the United States, they looked at the different click rates between the two regions. The graph below shows a histogram of the click rates for the last 5,000 emails sent out to each region. So you see that these distributions are actually different. The UK is flatter and wider, while the US is narrower and taller. And these are both the same number of emails. It would be problematic. You'd have to go through some normalization routine if the number of emails sent to the two regions had been different. They don't want you to worry about that because that just means one more step in your analysis. So here's a question. Describe the center, shape, and spread of the two regions. Based on the graphs, do you think the marketers have a reason to suspect that one region has a higher click rate than the other? Okay, so UK's distribution has a smaller spread. I think I got this wrong. Uh, the US distribution has, yeah, the US distribution has a smaller spread than the UK distribution. Okay, the UK is the dark one, right? But the center of the US distribution, I got these flipped, didn't I? Ah, center of the UK distribution seems higher than the center of the US distribution. Okay, both appear to be unimodal and symmetric. So they both look like they are Gaussian curves. Based on this graph, the center of the US, this is UK, distribution is higher, and we observe that we regularly observe a very low, less than 0.1 click rate. Yeah, about a 0.15 click rate, whereas the UK's distribution is almost never lower than 0.1. Okay? There is a lot of variability. There's a lot of variability in the UK's distribution. Okay, so more information is needed. But what we can say is they both seem to be normal distributions, right? So US, this is flipped, UK is higher than US. So there is reason to suspect that UK has a higher click rate. Okay. Okay. This is sample question 3. So we went from tennis to clothing and now to the medical field. Systolic blood pressure is the max blood pressure exerted on the arteries each time the heart beats. And the mean systolic blood pressure for an American adult is 122 millimeters of mercury, mmHg, and a standard deviation of 15. A fitness center would like to determine if the mean systolic blood pressure of its members is greater than the national mean. A sample of 100 members was selected. The systolic blood pressure for each member will be measured and recorded. And they actually tell us what we have here. So if mu is the mean systolic blood pressure of the fitness club's members, consider these following hypotheses. So they're telling us that they're looking at to see if this mean matches the basically the national mean or whether it is higher. Typically, you're concerned about higher because that gives you a higher rate for a heart attack. If it's lower, it doesn't. Got a little bit of information that you wanted to know, and probably, at least at this point, most of us may not care about right now. So describe the type 2 error in the context of the hypothesis above. So this is really testing, do you know the difference between a type 1 error and a type 2 error? So a type 2 error, what's good here is at least you can define what a type 2 error is. So that's when an alternative hypothesis is true, but the null hypothesis is not rejected. So that's the statistical definition. If you came up with something similar to this, that's great. So whenever they're asking you to describe something and you can define it, go ahead and define it. So in this situation, the type 2 error would happen if the mean systolic blood pressure of the population of the members is actually greater than 122, but the null hypothesis is that the 122 is not rejected. In other words, type 2 error would mean that the blood pressure for the fitness center's members is higher than the national average, but the test does not conclude that it is higher. So that's what we are looking at here. Okay. Typically, the first two questions, the first question for these types of the investigative task questions are relatively straightforward. So you can, basically, if they're relatively straightforward, yeah, those would be good to answer. The last few questions, the last question is typically a question that's asking about, it's a theoretical question. Sometimes it is a theoretical question. And if it is a theoretical question, testing your understanding of what's going on, then don't be afraid to answer it if you can't do the middle questions. The middle questions sometimes may be calculation intensive. So pick up your points where you can. Um, uh, sometimes you might be running out of time for these. They do suggest 25 minutes, but if some of the earlier questions, if you're taking the paper and pencil, take longer, then you may not have the time to completely finish these questions. Okay, so uh, basically, if we assume that the standard deviation of the systolic blood pressure of all members of the fitness center is 15 millimeters of mercury, and the mean is 122. So essentially, we're going with the national reported numbers. And samples for the selected is approximately normal with a mean of 122 and a standard deviation of 1.5. What values of the sample mean, would represent sufficient evidence to reject the null hypothesis at a 5% confidence interval? So essentially what I've been asked to do here is, so this is a one-sided test. Okay, so the null hypothesis would be rejected if I have a z-score that is similar to this. Okay, so this is of course a z-test. That's what I'm looking at, is z greater than 0.1645. You remember that you have actually gone ahead and memorized this number by now. So when you plug the numbers in, this is what you will get. Okay, so the mean that you will get then, given this null hypothesis, will be an x greater than 1.24.5. Okay, so really it's a lot of words here. As you see, the calculations are not so bad. What they really want you to do here is to say, okay, now that we have given you a real life application like this, in the real life application, can you apply the theory that you have learned, and can you apply it properly? So that's really what they're looking at. So yes, the calculations are important. Tell the test writer what you're doing. Tell them that this is what it is. This way, if you make an error here, or if you pick a wrong number, at least the test writer knows that what you're doing up here is actually valid, and you will get the points. If you don't do that, then they can't give you the points. Okay, so the thing for the investigative task questions is justify, 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 justify. Even if it's a straight calculation, at least tell the test writer what you're doing, um, just so that you can pick up the points. Uh, Even if you make a careless error, you can pick most of them up. So here is a nasty, right? The actual mean systolic blood pressure of all members in this fitness center is 125. So it's actually higher than the 122. Okay? Probably because it was taken after they worked out, so their blood pressure would be higher after a workout. Uh, we don't know that, but I just figured I'd put that in there. If they ask for what's the reason, if they all look pretty fit, I mean, this is after all a fitness center. So if it is a fitness center, you'd expect these members to be more fit than those people who don't work out. Uh, some of us couch potatoes who, when asked what do we do the year we stayed at home, the answer is I pledge the couch potato, 2 flights of steps, and that's about it. So 125 millimeters of mercury with a standard deviation of 15. So it's still the same standard deviation as a national average, but it's a higher mean. So using the actual mean from part A, determine the probability that the null hypothesis will be rejected. So now you got to do some calculations here. So essentially what we want is we want to know that the probability of X bar is actually greater than 124.5. Okay, so what that means is it means that the probability of X bar minus mu over sigma is actually greater than 124.5 minus 125 over 1.5. Okay, so basically what that does is that means that my probability that Z is greater than negative 0.355, which is 0.64. Okay, so using the null hypothesis, this is what we have as our probability. Okay. Oops. I forgot there was something there. I'll rewrite it. Sorry about that. I'll rewrite it. Okay, so P of X bar greater than 124.5. So this means P is equal to X bar minus mu over sigma is greater than 124.5 minus 125 over 1.5. So this tells me that Z is greater than negative 0.355, which is equal to 0.64. Okay. So D, what is the statistical term used for the probability found in part C? Now, this is actually the power of the test. Okay. So if you recognize that as the power of the test, then you know that, hey, the probability found in part C is indeed called the power of the test. Okay. Now, what they have here is suppose the sample size of the member selected is greater than 100. would the probability of rejecting the null hypothesis be greater than, less than, or equal to the probability calculated in part C? Well, what's going to happen here is that if we increase the sample size, now what happens to our error bars? Well, we become more certain, or we can have more certainty with the same range. So intuitively, if you increase, more data are better than fewer data points, right? So uh, now if it becomes larger, then the probability of rejecting the null hypothesis will be higher for a sample size that's greater than 100, because the two means are not the same. Okay, so intuitively, more data provides higher probability of a correct conclusion. So a technical explanation is that really this is still the same, right? We haven't changed here. But what we have changed is that the standard deviation has become smaller, right? So this is what has happened. Smaller standard deviation. Why is that? Uh, because our sample size has gone up, so we are dividing by the square root of n, remember? So therefore, the minimum value of the sample mean would be rejected if it would be lower, and in return, the probability of the null hypothesis being rejected, if the two means are not the same, will be higher. Okay, so approaching a digital test. So how do you approach the digital multiple choice test? And this is now, of course, while I said the digital test, the reason I said digital is because you can't reorder the questions. If you can't reorder the questions, this is the multiple choice test you have to work on. Of course, on the paper and pencil, if you decide this is the multiple choice test I'm going to work on, then that's the multiple choice test you're going to work on, and you would be following the same strategy. So what you want to do is read the question, of course, and your first line of defense needs to be which answer choices can you eliminate. Most test takers use this as their last line of defense. Use this as your first line of defense as to which ones you can eliminate. This way you can hone in on what the question is really asking, and you will be okay. You'll be fine as far as, hey, this is the way I need to go. Okay, so if it is an easy question, then finish your work. If there are calculations to do, go ahead and do them. If it is a hard question, or if it is a question that requires a lot of time, now you have a choice to make. Remember, time is a precious commodity on this test. So the choice that you have to make is, do I actually guess and take my chances now that I've eliminated, or do I actually finish the work? And a lot of that depends on where you are and uh, how far you've gotten and how much time is remaining. So that is something that as you practice more, you will learn to then judge what to do. And that is one of the reasons why, at least on the paper and pencil test, the do now, do later really helps, because this way you've picked up all the easy questions. These are the harder ones. So this is something you will have to work on. Of course, to be fair to the test writers, on the multiple choice, they try to arrange the questions so they go from easy to difficult. However, as we all know, that's easy to difficult as per the test writer. That is not easy to difficult for you, the test taker. You have your own individual preferences, which may be different from the way most people answering the test, which is how the test writers rate these, would work. Maybe you're very good at inference, which the test writers think are a little bit harder than uh, categorical analysis, for instance. Okay, so for a short answer, read all parts of the question. You can't go to the next question, but within a question, you can actually do parts out of order on the digital test. So read all parts of the question. This way, what it does is at least knowing what the second and third, well, second and sometimes a third part for the short answer, you know what the question is trying to get to. It gives you a better idea. So get that better idea. There are only three parts at the most, sometimes two. So you might as well read them both or read all three. So the default is to do the questions in order. They're written such that you do them in order, and they are written such that they ease your burden for doing them in order. Now, of course, while that is the default and that is what you want to do, because that, according to the test taker, is a path of least resistance, don't be afraid to do a later part if it is easier. And this is your caveat, if it is easier. The way the questions are written, they are written such that the earlier parts are easier than the later parts. Now, if that is not true for you, then yes, change the order. But most of the time, it should be true for most test takers. Okay, so before moving to the next part, make sure you have answered the question. This is important. So before moving on, just take a look at what the question is and make sure that you have answered it. It's amazing that we can do a lot of work and answer a question that we would like the test writer to have written, and we don't get points for that, unfortunately. I mean, at that point, uh, it is very difficult for a test writer to actually give you points for a question, for not answering the question, for answering a related question. Yes, your knowledge shows through, but the graders are given very specific rubrics. They're looking for very specific things. And if they don't see those, they just can't give you the points as much as they would want to give you these points. Okay, so for the investigative reasoning, there are typically 5 parts to it. I like to read all the parts of the question. Um, Sometimes what you may want to do is only read the first 2 or 3 parts before the stinger, uh, and then after the stinger. And if that's the way you want to think about it in your head, that's okay. I actually like to think of all parts of it so that while I'm working on the easier parts, the first part of it, uh, I am subconsciously thinking about the stinger as well that's coming. Okay, so that's what I would like to do. Write relevant formulas. That is optional. I mean, they are on your formula sheet. So if you may not want to write the entire formulas out, at least you want to make a mental note as to where they are on your formula sheet. Especially if they're very long, then you don't want to write them out. So that's why I put an optional. But if it's an easy formula, you may want to write it out. Okay. The default again is to do all the questions in order. Uh, but don't be afraid to do later parts if they are easier. Okay, so the last parts tend to be theoretical. Don't skip those. And especially on this one, justify your answer as much as you can. Okay, even if you write a couple of sentences for justifying your answer, it's a good thing. At least if you have picked up a wrong number someplace, it's easy to do that with these questions. You plug in the wrong number, at least the justification for your answer is going to give you most of the points that you have. It's easy in your writing to forget to write a square root. So remember that the justification here really does help you quite a bit. Okay, so how do you prepare effectively for the AP stats? Know the format and the instructions ahead of time. Understand the content that will be tested. So if you looked at this, I told you you could look at the content, but really understanding that, for instance, the investigative task problems, the way they are is that the first 2 questions ask about the task that is described, and then the third one actually throws in a stinger somehow. Just knowing that, now you are anticipating something different once you are done with the first two parts of the investigative uh, uh, the investigative task. So that is part of understanding the content that will be tested. Basically, knowing the layout of the terrain and the types of questions that they like to throw. So practice under test conditions, because by practicing under test conditions, you will be able to adjust your strategy, and your test will then tell you what are the areas you need to review. So know what content to, you don't have to review all the content. You don't have to review the content that you like. Your test will tell you what is the content that you need to review uh, to help you get a better score. And of course, celebrate after the test. Plan something fun after the test. So this way, no matter what, no matter how test day goes, you have something fun to look forward to. You can at least celebrate the effort that you have put in studying for the test. At least that is worth a celebration. Okay, so how can we help? Uh, Of course, at this point, this is the last section of my presentation. So if you have any questions, certainly queue them up for Shadna, and she will then send them to me. I know there's a little bit of a delay, so at least queue up your questions so she can start. Us at Princeton Review, what we focus on, our strength, is how to take standardized tests. Yes, the content is important, and without the content, there is no strategy. But what we actually pride ourselves with is, yes, you know the content, and most people taking a standardized test who have studied diligently know the content cold. What separates the top scorers from the let's say the 90th plus or the 95th plus percentile from, let's say, the 70th percentile generally tends to be the techniques. Okay, or sometimes even the 55th percentile. It is actually your test taking techniques. So how should you take the standardized test is actually huge. We have tutors and instructors ready to help you with the AP format. Okay, basically we have live streams like this one. You can have one-on-one tutoring. You can schedule that. We also have AP on demand tutoring for the most popular AP tests. And then we have our AP cram courses. The AP cram courses are designed to give you a crash course, so to speak, on the content that will be tested on these tests. Right? So at a minimum, take at least a practice test. They are available. Take at least a practice test to make sure you know what you're up against. To go through at least uh, so you can. uh, it's not just what you know. It's really how you physically handle the test, physically and emotionally. So at least you've gone through that experience once, and that makes you better prepared when you go through it the second time. I mean, ideally, I'd like you to take a few of these, uh, like half a dozen or so, before you take the real test. But if you don't have that kind of time, or the resources, you just don't have the tests, at least take one if you can. Okay, and we have our prep books. These prep books contain practice tests in them. Uh, they have at least 3 practice tests in them. The statistics one has uh, has 2 in it, and then there are 2 more online ones that you can take as well. So the statistics will give you a total of 4 full-length practice tests, 2 in the book and 2 online. So this is my last slide. I know this is my last session with you as well. And yesterday you saw some clip arts that were already on the slides. I have one more clip art for you today. It is actually my favorite clip art, because this is what I hope you do to the test. Uh, I hope you see her in the top right, to the right of the AP English Lang and Composition book. I call her the Karate Girl, because I hope you actually end up crushing that test. So I'll take any questions, and if there are none, then the very, very best of luck to you on your AP. Not only the stats AP, but all the other APs that you will be taking as well.